Hi Year 13s. In this video today, what we're looking at is working backwards to find a polynomial when we've been given the roots already. And before we get into that, I just want to talk a little bit about roots and the nature of roots. And so we're going to sort of start things off a little bit generic over here. And we're just going to write an equation like this, x minus alpha times x minus beta. And I just want to sort of think about what that looks like when we expand it. So if we're expanding this, we're going to get x squared minus alpha x minus beta x, and then plus alpha beta. And if we just collect our like terms here, we're actually going to write that as x squared minus, and then in brackets, alpha plus beta. You can expand those to check that it's right, and then plus alpha beta. And so this relationship between factorized and unfactorized versions of quadratics kind of illustrates a little bit of the nature of roots, where we can still end up with this positive common multiple of the roots when we expand it, and that's like the difference between the two versions of quadratics. So hopefully that will just keep that in mind as we approach this next problem. So this question says, give the polynomial, so that could be x squared or x to the 3 or x to the 118, and they're asking us to find a polynomial with roots 1 and I, multiplicity of 2. And what that means is that that last root I has been repeated twice, and what that means I'll show you in a minute. So with this example, our roots are 1 and I. So that's sort of why I showed you that stuff before. So our polynomial could be written as this, x minus 1 and x minus I. And then this multiplicity of 2 just means that x minus I repeats itself. And so it's a root in both cases, but we've actually got a cubic rather than a quadratic. So we really ought to expand this. So I'll expand this part first. So I'll just write that x minus I by itself out here, and we'll expand it. So we've got x minus 1 plus I. Oh, that should be x squared there. 1 plus I times x plus I. And now we'll expand it again. So we're going to have x cubed minus 1 plus I x squared plus I x, and then we've got minus I x squared plus 1 plus I times I x, and then minus I squared at the end. Okay, so we'll collect like terms here. So we'll start with the x squared terms, and so we can write that as negative 1 minus I, so that's going to be minus 2I. So sorry, I'll write the x cubed term first. So we're going to have minus 1 plus 2I x squared, so that's simplifying those coefficients here and here. Okay, and then we're going to get our x terms together, which are these two here. So we're going to have I x plus, and I'm just going to expand these brackets, so I plus I squared x, and then I squared I'm going to simplify to plus 1. Okay, take it another step. So I've got x cubed minus 1 plus 2I x squared, and that I there is going to become negative 1, and so that I squared is going to become negative 1. So we're going to end up with 2 i's minus 1 in front of x, and then 1 by itself. And so that's our fully expanded version of our polynomial, and that's really what the question there is asking for. Okay, So you've got some very similar problems there, so it should be pretty straightforward to start out with, but just get your head around those ideas of roots, and you just have to be very particular with your algebra here to make sure that you're spot on when you're expanding these things. Okay, thank you.